Unit 3, Part 4 notes, I can solve and graph a multi-step linear inequality. First, just a reminder of your key terms, vocab. We got like terms are terms that have the same variable part, and constant terms are that term with no variable part. When we combine like terms, we can only add and subtract terms that have the same variable part. And reminder that x is different from x squared. So those are two distinct like terms. And then distribute is that multiplication over addition and subtraction. And then next, that inequality vocab. This is all stuff that has been covered previously in the unit. It's just important to go over and refresh our memory each time we work with it, as it is essential vocab. So an inequality is a mathematical sentence formed with one of the following symbols. We have our less than and greater than symbols, which do not have that line underneath them, and they leave an open circle when we graph them. And then those less than or equal to, greater than or equal to, we add that line underneath them. It's really important to note. And then that circle is closed. And solving multi-step inequalities is just like solving multi-step equations. So we're really continuing what we did in part 3 into this part 4 lesson. So let's get into the practice. We are going to solve and graph the following inequalities. Now, the new piece for this lesson is not only having the inequalities that we're working with, so it's just going to be a different symbol in the middle instead of an equal sign, an inequality. Same concept, we're still going to draw the line, we're still going to do the same thing on either side of that line. But we are also adding a new second step, which is to get variables on one side. So one side means one side of the line. We either want all of the variables on the left side over here or on the right side over here. Doesn't matter which side the variables are on, but they all need to be on one side. So if you look right now, in this example, we have 7x is on the left side, but 9x is on the right side. So we have variables split. They're on opposite sides of that line. We need to get them over to one side. So that's going to be a new step that we're going to be covering, and we're going to talk about it right now in this example. But if you notice, all the other steps have stayed the same. So those are not new steps. Those are things you've done before. We're just popping a new one into something that you already are very familiar with. So let's go ahead and try this. We have 7x is less than or equal to 9x plus 10. So when we look at our steps, the first step is always distribute. Now distribute, we know, needs parentheses. In this case, we don't see any parentheses, so we don't have to distribute. What we do have to do is get our variables to one side, which we've already talked about. So to get our variables to one side, we need to figure out how to make one side have 0 x's while having the other side have all the x's. So on this example, I'm going to take this 9x and I want to get it to join the 7x. Now since it's on the opposite side of the line, we have to do the opposite operation. I can't just pick up the 9 and add it to the 7x and make 16x. That's not how that works. That's not a balanced inequality or equation. So with this 9x, we have to figure out how to make 9 become 0. So to make 9 0, we do subtraction. Or we can think, since it's a positive 9, we're going to use the opposite, which is negative. So negative 9x. If I do that on the right, I have to do that on the left. I'm going to subtract 9x from both sides. 7 take away 9 is negative 2x. 9 take away 9 is 0. And then we have 10. So now you can see all of our x's are on the left side, and we don't have any more x's on that right side, which is what we want. Get variables to one side. They're on the left. So we did step 2. Combine like terms. I'm looking. I don't see any like terms that I can put together because I just have the x's on one side, the number on the other. So really all I have left to do is this undo multiplication and division. We have times here. We undo that with divide by negative 2, divide by negative 2. That leaves us with x and negative 5. Now here is where it's really important to remember that we're working with an inequality, which means when we do that divide by a negative, when we divide both sides by that negative value, we have to remember to flip that inequality. So instead of it being a less than or equal to, it's now going to be a greater than or equal to. So x is greater than or equal to negative 5. I'm going to put negative 5 in the middle of my graph. moving towards 0 on the right side, moving away from 0 on the left side of that -5 value. Close circle at -5 because we have that line underneath the inequality. And greater than, so we're going to move towards where 0 would be, which is to the right. All right, another example. We have -10 plus 8g is greater than -4g plus 2. We go ahead and draw that line. And again, we look at our steps. We don't have to distribute because there's no parentheses. But again, we do have those variables on both sides of that line, both sides of our inequality. So we have to move one to the other side. So I'm going to move this -4g over to join the 8g. Now again, we have to use that opposite operation. It's on opposite sides of the line, so we have to do the opposite. The 4 right now is negative, so I'm going to use the opposite, which would be a positive, or addition. Add 4g. And if I do that on the right side, I have to do that on the left side, keep it balanced. Now when I add that 4g, I want to make sure I line it up with that like term. We have 8g right here. I'm going to line it up with that 4g right there. So when I simplify this, -10 just comes down. 8g plus 4g is 12g, is greater than -4g plus 4g, that makes 0, but we still have this plus 2. And since I'm bringing it down, since there's no longer anything to be adding to it, it's really 0 plus 2, because when this 4g cancels out, it becomes 0. So 0 plus 2 is just 2. All right, so now we need to undo this -10 with a positive 10. -10 plus 10 is 0. We're left with 12g is greater than 2 plus 10 is 12. Last step, we divide both sides by 12. We get g is greater than 12 divided by 12 is 1. No need to flip the inequality this time because we divided by a positive number. G is greater than 1. We just need to graph that, so we put a 1 in the middle. Greater numbers on the right, smaller numbers on the left. And then we have an open circle at 1 because it's just greater than, not equal to, but it is greater than, so we're going to shade to the right. All right, there are 2 more examples. However, for the sake of time, I'm just going to go through the left example. We're just going to skip this right example just to keep this video hopefully closer to that 10-minute mark. All right, so we again have our steps to solve. This time we do have parentheses, so we are going to do that distribute step first. So we're going to do -2 times 3x, which is -6x. And then we're going to do -2 times, and I'm going to make that -5 with that minus sign. A negative times a negative is a positive, and then 2 times 5 is 10. Is greater than or equal to -2 minus 9x. So that took care of that distribute step, so now we're going to get our variables to one side. I see I have -6x over here, and I have -9x on the right. So I'm going to move the -9 to join the -6. Opposite of -9 is positive 9. So I'm going to add 9x to both sides. -6 plus 9 is 3x. Still have that plus 10. Is greater than or equal to. -2 is still there, but -9 plus x is 0. So we did that, we combined our like terms. Now we have to undo addition and subtraction. We have plus 10, so we're going to subtract 10 on both sides. 10 take away 10 is 0. We're left with 3x is greater than or equal to -2 minus 10. So I'm at -2. I go 10 more negative, which gives me -12. And now we're just left with undoing that multiplication with division. So we're going to divide both sides by 3. X is we keep the inequality the same, greater than or equal to. Negative 12 divided by 3 is negative 4. Now we just have to graph that, negative 4 in the middle, smaller numbers on the left, larger numbers on the right. Greater than or equal to means a closed circle at negative 4, and then we're going to shade to the greater than numbers. All right, that's all your notes for today for your practice. That will be an online activity on Schoology, so you can go ahead and do that now.